My talk today is going to be about policy as code, sort of more generally, and then we'll talk a bit more about kind of a specific framework that we introduced last week called Sentinel. For those of you who don't know me, my name is Armon Dadgar. This is my first Strange Loop, actually, so I'm super excited to be here. I've heard only great things, so I'm excited to be able to come out here and present. And for those of you who don't know me, I work at HashiCorp. I'm one of the founders and CTO. Oftentimes, people know us less by the name of the company and more by the name of our tools. So you might have played with Vagrant or Terraform or one of our other tools. So I'm not going to necessarily talk about any of these tools specifically today. I want to talk a little bit more broadly and more generally about policy as code. But before I talk about policy as code, I want to sort of set the foundation by first kind of going back a step and talking about infrastructure as code, which is much more of sort of our traditional wheelhouse, and if you've played with tools like Terraform and Packer, that is sort of their driving motto, is this notion of everything should be sort of codified and your whole infrastructure should be driven by code. So we'll sort of talk about the evolution of infrastructure as code and sort of the how and the why and the what. So in sort of the world before infrastructure as code, how did we actually provision our data centers, bring up VMs, manage our sort of multi-layered infrastructure? It was honestly, it tended to be a little more artisanal and handcrafted is sort of what we saw as sort of the standard, right? People would log into user interfaces and sort of point and click to boot a VM, and if you needed 100 VMs, you just point and click 100 times more. And so there was a lot of this sort of manual, bespoke management of things, right? Very often UI-driven, very, very common to see sort of just SSHing into production and sort of apt-get installing the appropriate set of packages, maybe rsynching things between machines. But in general, it was the sort of more handcrafted approach. And this was kind of fine when we only are talking about a handful of machines, right? It's sort of overkill if you're only dealing with a handful of machines to really automate this whole thing. As we saw more scale and sort of more need to have rigor and sort of operational discipline, we've seen infrastructure as code increasingly become sort of the common approach, right? The idea being here, how do we have sort of a single source of truth in terms of how things are actually supposed to look instead of, we apt-get installed 5 packages on this machine and 6 packages on that machine, and they both seem to work. And so you're in this sort of world where you're like, there's really no particularly well-defined source. It's sort of like the things that exist and are working are kind of the source of truth. So moving away from that to actually having that definition, that source of truth. And then if you have this, it lets us get into this world of automated provisioning, right? So now, great to stamp out one VM, we just run this sort of codified definition. If we want the 1,000th VM, right, we're just doing the same thing in an automated fashion 1,000 times. So it enables us to get to scale in a lot more sort of a sane fashion. We don't have this sort of, artisanal management times 1,000. And in some sense, it's this sort of transition from, if we're building 1 or 2 things, it's fine for it to be handcrafted, but if it's something where we expect to be doing, 10 VM deploys a day times 100 or times 1,000, it starts to just become impractical. You need a little more automation, you need a little more standardization and rigor on how this is done, right? And so it makes sense that this becomes sort of a natural evolution to say, how do we reduce the sort of error in this? Much like, going from handcrafted thing into sort of an automated factory. And so what are the benefits as we start going down this route? In some sense, it's kind of just porting over all of the things we learned from software development, right? It took the software development community many, many years to sort of establish what are best practices around version control and peer review and branching and merging and having these sort of higher level sort of hygiene that we apply to the practice to make software of higher quality. And in some sense, what we're trying to do is drag that over to kind of how operations folks do things, which is closer to I manage the source code on my laptop and FTP it to production. It is sort of state of the art. And so if we bring this sort of notion of, hey, the things that we're doing in software development actually apply to operations if we take an infrastructure as code approach, then we kind of get all the same benefits. We get versioning, and we have rollback into older, well-known states. We can do peer review, so we can ask, hey, fellow operator, can you look at this? Does this make sense? You can start getting abstraction and encapsulation, so defining sort of higher level modules and sort of treating that as a black box. And then we can start getting code reuse across our organization. We're not sort of just reinventing the wheel all over the place within our organization and across sort of the community. And what all of this leads to is sort of more automation, more leverage, so that you can manage sort of larger fleets more easily. And so great, can we just adopt this sort of infrastructure as code approach, in a silo without really, changing anything about the world around us? And it turns out not really. There's sort of some prerequisites to making this approach actually work, right? And so in a traditional sort of provisioning a data center world where we're actually buying from, HP and racking and stacking, there's a lot of people involved, right? You have your developers who have some guess about how much hardware you need. You have finance who have some CapEx budget and a different OpEx budget. You have procurement folks, IT op folks, legal, networking, so on and so forth. And all of these different groups have to be sort of coordinating in terms of provisioning that data center. And so this gets to be a really challenging situation because it's very hard to codify all of these roles, right? They tend to not like that. And so there's this sort of prerequisite, which is you actually need to hide a lot of these things behind an API before this approach even starts making sense. Because otherwise, there's really no good way to deal with your legal department in an infrastructure as code way. And so you start needing to say, okay, how do we replace these various ticketing workflows that were sort of flowing through the system with API contracts, right? Because if we have an API contract, then we can automate it, then we can wrap it and apply a sort of infrastructure as code methodology to it. And so in some sense, the big push that started making a lot of this possible was public cloud, right? It started consolidating many of these different concerns and putting them behind an API for us. And so private cloud is sort of catching up, but in some sense, what it's trying to do is provide those same APIs. And so once we have these APIs, once the API sort of approach is ubiquitous, then it really enables infrastructure as code. Because now we can think about sort of booting a VM or managing a DNS record or managing our CDN all as just various API calls. And so this starts to lead to a huge increase in our leverage. The challenge with that is this notion of sort of the paradox of automation, right? Is that once you have huge leverage, it can be used both for good and for bad. And an example of that is, what if I just fat finger and it's like I meant to provision 50 VMs, but I accidentally put 5,000, right? Traditionally, if I sent that ticket over to procurement and they're like, well, last year you bought 40 and this year you want 5,000, they're going to come back and say, are you sure, right? They're going to be like, this doesn't really make sense here. If you ask the cloud to provision 5,000 VMs for you, it just says, great, no problem. Here's 5,000 VMs. Like, we're happy to bill you by the minute. And so there's like this loss of sort of sanity checking of the sort of context that a human would have, right? Your legal department or your procurement department has some context as to like what is normal and what makes sense to be done, right? If you call the networking team and say, my app's not getting traffic, can you just route the cables around the firewall? They're going to be like, that doesn't make sense, right? Versus AWS, you're like, set every ingress rule to allow. Cool, great, let's do it. And so we lose this notion of sanity checking, right? And so we get into this interesting paradox of automation where we have this incredible leverage, right? And we can do things at huge scale, but then it sort of opens us up to this new set of challenges that we didn't really have, right, before, which was one of the big ones is just accidental error, right? I just fat finger 5,000, right? Before there was enough sort of checks and balances that somebody's going to catch it, hopefully, right? Or, if nothing else, finance catches it. Then you have issues of sort of compliance bypass of like, and this is not malicious, it's just sort of like my app isn't getting traffic. It seems to work when I disable the firewall, right? In sort of a more traditional world, you can't ask the networking people to route the cables around the firewall. And then the last one is sort of malicious intent, is like if I actively want to bypass controls, right, for sort of malicious reasons, who's going to stop me? And so all of these things sort of lead us into thinking about, is there a different way of doing this, right? And this is sort of how we started getting to this notion of policy as code, is how do we actually govern what infrastructure as code is valid, right? So that you can't just write whatever you want and be like, yeah, just set every ingress rule to allow. And what we really want to do is not sort of have a sort of checkpointed human sort of ticketing process again. It's really how do we define that sandbox such that as long as you're inside the sandbox, run free, do whatever you want, right? Provision 50 VMs, provision 100 VMs, don't provision 1,000 VMs, right? And so if we're within it, we want people to have that leverage, have that sort of agility, but then we want to bring back that sort of sanity checking that we had before, the sort of like, are you sure you're doing this right? And so part of this is also how do we get back to a little bit of that separation of responsibility of having this like, the sort of secondary group that's doing the sanity check, because that does give us this sort of bulkhead against failure. If you're just doing decisions unilaterally, there's no one second guessing anything. There's no one saying like, are you sure? And so part of it is not let's have a person do it, it's can we have two different sets of codified rules? One is the infrastructure as code, which is evolving rapidly and is being written by sort of operators that has this huge leverage, and maybe you have a separate group that's defining what that sandbox is. And the sandbox should be a little more static, but this way it's sort of the, it's the separation of, you don't want a bug in both the code to affect sort of the test as well, right? It's like, as long as the test is sort of an independent verification of the code, it gives you this sort of sanity checking that they're not both wrong. And so part of it is, it's a separate set of code written by a separate set of teams that's providing this bulkhead against failure. So, okay, let's look at sort of policy as code more broadly. What are the kind of things that we start wanting to enforce if we think about this sort of meta construct, right? If we have code that's governing our infrastructure as code, what are the kind of things we look at? Part of it can be things that are actually not even about the code at all. They can be sort of just like process workflow changes, which is, maybe I only want changes to take place during working hours, right? Like, I'm glad you're really excited, but please don't deploy to production at like 2 a.m. on a Saturday, right? Like, you make everyone's life more challenging. Then there's things that are actually specific to kind of the actual application. Maybe we say, what, we want to have a minimum and a maximum number of sort of instances per service tier, right? We don't want to have only one instance because then, there's no sort of availability in case that one node dies, and we also don't want, 10,000 instances because we're paying by the minute. Then you get into things like, what about which types of instances are allowed? Like, do we want to standardize our fleet on only a handful of types of instances, or you're not allowed to go spin up, the 512 gig machines? Then you get into things like public cloud regions. So maybe staging is always US West and production is always US East. How do you enforce that so someone doesn't just accidentally deploy, staging traffic into production? And then you start getting into some of the more sort of like enterprisey concerns, which is like, how do I make sure any resource I boot, I'm tagging it with sort of a billing sort of a key or a tenancy key, like which sort of line of business owns this resource? Or if I'm deploying out into production, how do I make sure it's not just, developers are picking a random black box with, 50 known CVEs and deploying it straight into production, right? It's like, is there a curated list of containers or AMIs that were said, yeah, these things are certified, these are what you're allowed to deploy, not just like whatever you found on the marketplace. And so what are the sort of organizational challenges you start running into when you start thinking down this approach, right? Which tends to be a very sort of developer-operator mindset, is that oftentimes it's not the developer-operators who are caring about these problems, right? It's the security and compliance teams, right? It's their jobs to define and enforce these policies, and they're not traditionally familiar with an as-code approach, right? They take a more as-Word doc approach to things. And so how do we get them to be familiar and comfortable with this way of doing things, but also give them ways to sort of build sort of confidence, to be able to test their policies actually are doing what they think they're doing, right? Because in some sense, the goal is to remove people from the enforcement path. And so this brought us to a project that we called Sentinel. It really grew out of just working with people on the infrastructure as code side and trying to answer a bunch of those questions they had, which is like, how do we actually impose some sanity around what's being provisioned without having to have an army of people just doing code review all the time? And so our project, the Sentinel as Code project, that I'll spend some time talking about, is sort of one stab at taking a look at how can we think about policy as code as sort of this broader effort, right? And it's really 4 different pieces. On one side, it's a language specification. So we've published this sort of open spec in terms of what this language looks like. There is, we have at least one runtime implementation of it. We expect there will be more runtime implementations. A simulator tool, and we'll talk about how and why that's useful. And then an import SDK, and sort of a way of thinking about import, sort of external information into a policy. So starting out, even before we get into it, is like, what were the goals here? What were the goals in terms of while we were thinking through a policy as code sort of approach? One of the biggest things really became that it has to be non-programmer friendly. And this had a lot of implications, is that we very quickly found the kind of people who are reading and writing these policies are not sort of traditionally developer backgrounds. So how do you get them comfortable with what's going on? It has to be sort of easy to embed, and we'll talk about why. We want the language to be simple, debuggable, and Go friendly. And we'll talk about sort of why. Some of those maybe don't seem obvious. So this one was really the biggest issue we found, is that the language is largely going to be read and written by those with little to no programming experience. So it's not that these folks don't want to learn, they're happy to learn, but they're not coming from a background of, hey, we're just going to throw you into sort of an object-oriented system and have fun with this, right? Like they at most know a light bit of sort of shell scripting. And so how do we make them comfortable as they're learning and sort of easing in here? And so we want the traditional constructs to be available as well. If you have a really complicated policy and you're like, hey, I'm just going to borrow a developer for an afternoon and have them do it, you don't want them to feel wholly out of place as well of like, what is this thing? The other one that's super important was that it had to be easy to embed, right? And this really is more of an impact to the runtime than the language. There's elements of the language that get impacted by this. Particularly, we don't want support for things like unsafe, arbitrary memory access. It makes it hard to embed something if that's possible. And so it must be easy to sandbox the application. You don't want it to be able to do unsafe things because it's running within the context of some sort of parent application. And if we can actually embed it, then what we can start moving towards is this notion of active enforcement, which is how do we prevent a violation from happening, as opposed to passive enforcement, which is we can just detect that a violation has occurred and sort of trigger some remediation workflow, right? And so it's much, much easier if we can be in that active enforcement path and just not have to deal with a compliance issue beforehand. The next one that was important was simplicity, right? Having simple types at the expense of performance or exactness. And part of this will really comes back honestly from that first one again, which is sort of complex types are hard to explain, like the difference between float 32 and float 64 to someone who doesn't have programming experience. They're like, what difference does this make? And you're like, it's kind of hard to, you're like, it doesn't really matter anymore. And so then the other one is really how do you make sure these policies are relatively simple to write, and because they don't need much flexibility, right? Like the kind of things you're implementing are like, here's this 100-page Word document of policies, and you're sort of translating that into a codified definition. So you want it to be a relatively simple translation. They're not doing, you're not writing your application in a policy language, so you don't need crazy flexibility here. And you want it to be sort of ideally one way to do something right, sort of in the vein of Zen of Python. You don't want there to be 50 ways to achieve the same goal. This way that you get some sort of standardization of if 10 people write the same policy, it effectively kind of looks the same. All 10 versions are identical. The big other one is, especially for people coming in without sort of a traditional background, is making it easy to debug, right? How do they understand why the system isn't working? Why did the policy pass when you didn't expect it to pass? Why did it fail when you didn't expect it to fail? And we find that this is often one of the sharpest corners when learning a new language, is just the debuggability and feedback loop of the system, right? Most languages are not too complicated to learn if they have a good feedback loop. It's when they have a terrible compiler error that's just like failed to compile, and you're like, great. The other big one that was really more important for us than sort of more broad to sort of policy as code was this notion of Go-friendliness. The majority of HashiCorp's tools are written in Go, and so it was just important for us that whatever we're sort of using is easy for us to embed in our tools, right? So we want it to be simple to integrate, minimal changing to the rest of our sort of tooling and process, and to not have sort of performance implications. And that was sort of a big one when we started looking at different options. So the first sort of big question, right, and this was a big question internally too, is like, how do we avoid inventing a language, right? Like, ideally, we don't want to do that. We don't want to have to educate people on something new, because then it's like all of the burden of sort of education becomes on us as opposed to like if it's an existing language. And so we really started out with this, right, with the intent that we'd be able to sort of fit it into an existing language and get it to sort of work for us, and maybe there's a higher level framework that we have in terms of helping people make it sort of simpler, but that it would be a DSL in one of these languages. And so honestly, the big two that we started with and spent a lot of time with was JavaScript and Python. Lua and Ruby to a lesser degree. But ultimately, it really came down to those three issues that made it really hard for us. One was the sort of, how friendly is this to non-programmers? How much time are you spending sort of teaching sort of programming constructs as opposed to just like, they just want to be able to write policy really easily? How easy is it to embed in the tools and sandbox effectively? So sandboxing the execution of it was obviously important for us, given that it's embedded in our tools. And then how friendly is it to Go? And we really struggled with all of them in terms of trying to hit all of these requirements. We probably got the closest with sort of Python, and you can kind of see when we talk about syntax that it reflects sort of very Pythonic kind of views. And so we didn't find a way to make any of these work for us, and so we started saying, okay, if we were going down that route, what are some of the design decisions we'd start to take based on our express goals? And the first one, the biggest one that had kind of the most impact to the design of the language was dynamic typing. And in some sense, it was much against our own will, right? We wanted the system, writing everything in Go. We're very happy that you get these like great feedback from the compiler when you have static types. It's just a lot more sane as a developer. But what we found is it's just so much friendlier to non-programmers, if the type system is dynamic, that it was almost just became a no-brainer, right? The whole, like, explaining a type system to someone, it really just sort of derails the whole thing pretty quickly. And so it's like, okay, just from a pragmatic standpoint of the people we expect to be writing this don't want to deal with a type system, we have to sort of hide that from them. The other thing that made it much, much more complicated is sort of external integrations, right? So if you start sourcing data from external systems to make policy decisions, and we'll talk about what that looks like, it becomes a lot harder because now you need sort of schemas that expose like, okay, this is what the format of the data coming in from the other side is going to be, here's the types that you should be expecting, and then you start getting really weird errors when the types mismatch. And again, you're dealing with people who aren't sort of familiar with type systems, and so they're getting like typing errors. And so they really don't like that. So then, here's a quick snippet, and we'll get into more of the syntax of it in a little bit of what Sentinel actually looks like. One of the other things that was important was this notion of a first-class rule. So I've sort of bolded them here, is that these are actually first class to the language itself, right? And we'll talk about sort of like why, right? Why have this notion of a rule? In some sense, rules are actually equivalent to a function. So the language also supports functions, defining and calling them. And so why bother with a specialized construct? Well, it turns out on one side, functions seem sort of scary to people. It goes back to the sort of friendliness. They're like, it makes it, again, seem like they're programming, versus when you're like, no, you're just declaring a rule. Then all of a sudden, it doesn't seem like you're writing a program. And so it's like, we can just rewrite it to being a function without them realizing it's just kind of syntactic sugar. The other things that became nice about having this thing as a first-class sort of construct is just by watching how people would translate their sort of written policies into actual policy as code, is it's incredibly redundant, right? Like if you've ever read one of these sort of compliance guides, it's sort of, every sentence sort of repeats 90% of the previous sentence. And so when it gets translated to policy as code, it kind of looks exactly the same. It's like most of the code is like highly redundant. And so what we did once we sort of built out this notion of a first-class rule is to make it lazy and memoized, right? So we actually only evaluate the rule if there's some other rule that's referencing it that we have to get to. And so if you have these incredibly redundant rules that really only apply under specific situations, you're not evaluating them most of the time. You just sort of skip the rule entirely. And then you can memoize them so that you're not getting this performance penalty for basically expressing the same logic over and over and over again. And this is particularly important when you start talking about sourcing things from an external system. So an example of where we would see things like this all the time is maybe you have a rule that's like, we're going to call out to some external system with some expensive call. So we're going out over the network, we're going to query some system, it's going to take 20 milliseconds to get our response back, and then maybe we have some other rule that's saying like, are we in an internal override? And you'll start seeing things like this all the time, where you're like external ready or not external ready and internal override. And so if you didn't memorize this, you start making this redundant call over and over and over again times 10 per policy evaluation. And so yes, you could sort of just have them define it as a function and then memoize that value into some other variable and reference that variable, but then it's like that becomes a very programmery way of thinking about it. Like they would not think to, I'm going to write a function and then memoize its value and then use the variable. Like they just don't do that. And so in some sense, by just wrapping it in this rule and doing this behavior for them implicitly, they can sort of just do the rote translation from here's the Word document into the rule without getting this sort of performance penalty. It's like they can sort of just translate it and it sort of does the right thing. They get sort of optimal performance. The other big one was this notion of dedicated existential operators. So again, this has just become syntactic sugar. You could do this by just having a for loop, and the language has for loops. But it turned out that so many of the policies that we'd see basically fall into these two categories, where you're like, all of the artifacts that we're deploying to production must come from a trusted source, right? Or any of the tags on the instance, one of them must be the billing ID or the tenant ID. And so it turns out most policies are sort of like any of, all of type of expressions. It's very rare that's like, half of the things we deploy should be trusted. The other half, like whatever. So you just don't see that very often. And so in some sense, these things are just, again, syntactic sugar around for loops and maintaining basically a Boolean sort of counter and then doing some short-circuiting if possible. The other one that was big was just plain English operators, right? So in addition to sort of the standard like, equal, double pipe, all of those things, just having the sort of Pythonic English equivalent of and, or, contains, in, makes the policies both a lot more readable and it just seems less scary to people coming in. So all the traditional operators that are the equivalent are all there as well. So if a developer is sort of working on it, it won't feel like, annoying that it's totally retooling it. But for folks that are less familiar who want sort of a more friendly looking syntax, they can use the sort of more English operators. The other one that was big from the design of the language was how do you handle errors? How do you actually handle things that don't make sense, right? There's a few different sort of paradigms that we've seen borne out in terms of do you just return an error? Do you have an exception workflow and sort of control flow around that? Do you return undefined values? So there's a few different things there. But at the end of the day, errors exist and you have to deal with them somehow. You must propagate the error. And so the direction we ended up going with was this notion of sort of the infectious undefined, right? Is that if you hit one of these errors, the result is actually just an undefined value, and that value then interacts with other operators by causing sort of more undefined results. And the idea here is oftentimes what we found is these undefined values would be escaped by other higher level Boolean logic, right? And so most of the time, the undefined actually just gets dealt with sort of naturally, and then otherwise there's an explicit operator that will deal with it. So I'll show you what I mean by this. So here's an example of a policy where we expect valid bar to get basically evaluated as undefined. So here, very specifically, we're setting the object to null, but you can imagine the higher level system, maybe object is sort of a request object. So there's a request being made to the system, and we're sort of introspecting on this request to be like, did this particular value the user pass in, is it equal to 42? Well, what if they didn't pass in that value, right? Or the request isn't fully sort of properly formatted? This is going to be undefined. So instead of exploding, what will happen is valid bar just gets lazily evaluated and saved as being an undefined value. And that's fine, because then valid time maybe is actually valid. Maybe it's after 8 a.m. And so when the rule evaluates, it hits this clause that's basically valid bar or valid time, which is undefined or true, right? And sort of anything or true, logically, is true. And so the system sort of escapes being in this undefined value, right? Because it doesn't really matter what the value of valid bar is, because the higher level logic is saying, I don't really care what the value of bar is as long as the time is valid. And so we sort of end up escaping that. And then if we're in a situation where neither bar or time are valid, then the else clause is sort of an escape, because undefined or undefined, it becomes undefined itself. And then else, basically, the operator acts as, if the left-hand side is undefined, take the value of the right-hand side. And so we'll sort of escape the fact that both of them are undefined and end up at a false value. And so it makes it a lot easier when you have these deeply nested sort of rules where you're just introspecting on these deep structures and saying, like, does it match what I think it does, to just get this undefined value that oftentimes gets sort of naturally papered over by a higher level kind of construction. Cool, so now I wanted to do sort of just like a brief tour of some of the syntax. We won't make this exhaustive. The specification is online, so feel free to check out for the extensive syntax. But some of this sort of just showing off kind of like what the higher level kind of constructs and ideas and how this translates from sort of the design principles. So here's a very simple policy, which is basically just ranging over a set of objects and just saying, hey, every one of the objects that we get must validate against this particular regex. And it turns out this is a really common type of policy that you see, which is like, I want to canonicalize all of my inputs. It should kind of look like this, and I just want to make it easy to sort everything is like that. And so this sort of shows both the power of having that sort of existential all operator, right? It makes it a lot easier instead of saying like, all true and then doing a for loop and breaking out if it's false and doing all of that. Instead, it just becomes a one-liner. And then matches, doing sort of a regular expression against a string, we've integrated it as a native sort of operation. So if you use the match operator, it expects the right-hand side to be a regex, and it compiles that and saves that so that you're not recompiling the regular expression all the time. And so this becomes sort of a really easy rule to understand what's happening here. Here's one that shows kind of more of the sort of standard programming constructs of it, where it's like we actually have a function call and we want to do sort of a traditional for loop and increment a counter. It still ends up being pretty simple. We'll start out in sort of our main rule block, and then we can call into a function and we sort of have the normal kind of, looks like we're just writing Python almost. And then here's a little more of a complicated one, looking at basically what if we want to restrict, in this case sort of vaguely based off of Terraform, what are the sizes of instances that we're actually allowed to deploy, and what are the regions we're allowed to deploy in, depending on if we're in staging or production. So here we basically have one set of rules that's checking, are we deploying into the right region based on the environment that we're currently in, and the other one's checking are all of the instances, the correct size, right? And if those two are valid, great, this sort of infrastructure as code definition looks good. So that covers sort of from a high level the kind of design principles behind the language, a little bit of what the syntax looks like, hopefully gives you sort of a flavor for it. So what does the actual runtime of Sentinel look like? We decided to keep it very simple. And so, it's almost as simple as something like this can get. And we'll sort of talk through its pieces, but it has, standard Lexer parser, semantic checker that it uses a sort of an evaluator interpreter, and then it has a built-in standard library. So the Lexer parser is actually pretty heavily borrowed from the way Go does it. They do a really good job maintaining sort of all of the offsets and providing sort of user-friendly error messages in terms of like where a syntax error happened, and sort of collecting multiple errors at a time instead of bailing on the first one. And then supporting a native sort of writer or a fumped command. So there's sort of one true way to do it. This has been something that we've loved at HashiCorp, is that there is no sort of religious wars about what is the correct format. It's like there's one source of truth, and it's whatever GoFumped says it is, right? And so it doesn't really matter, what your opinion is. It's like run it through GoFumped. And so we wanted to have that same sort of thing where you don't have a sort of battle around, what's the right syntax for this policy. It's like, who cares? Write it however you want, then run it through Fumped. It always comes out the same. And so this canonical format, we found it to be really nice, and we wanted to bring that over to Sentinel as well. The other one then is once we've actually parsed it and built out the AST, can we do some amount of semantic checking to ensure the program won't explode once we're running it? And so this gives us an opportunity to kind of give an early warning to users for any obvious type errors, any sort of obvious, it doesn't make sense the way these functions or rules are being referenced, making sure the main rule actually exists, so you've defined a policy that can be enforced. If you're importing things, that the imports are actually valid and available, things like that. And then it gets into the actual evaluator itself. So the evaluator operates directly over the AST today. There's some stuff we've sort of talked about around, eventually do we do some amount of sort of translation to bytecode or even, potentially JITting it. But for today, it's a pretty basic AST walker. And there's a few things that the runtime does. One is, as we mentioned, kind of that rule memoization. So we see very, very redundant sort of evaluation of rules. So how do we make sure that we're sort of just memoizing? Policy caching, so it tends to be that you're evaluating the same policies over and over and over. So caching sort of the parsing of the tree. And we'll talk about imports, but there's a lot of work around making imports efficient, because it turns out spinning up and down plugins is sort of time expensive. So we'll talk about that in a little bit. And then sandboxing is a big one. So because this is embedded and running within the application, we want to make sure that you can't run for an arbitrary amount of time, you can't use an arbitrary amount of memory, your stack depth is limited. And so these things are operating in a pretty small sandbox. They really can't do a whole lot outside of that. And then sort of the final piece is how do we avoid user functions, right? User functions really just begin making the system feel very programmery. And so oftentimes we want the policies to be able to be written entirely with sort of built-in functions. And so it's important to have a standard lib to sort of escape that, right? So for a lot of the common things that we saw was things like, dealing with time, dealing with math, parsing of CIDR blocks, like is this IP in our corporate network, things like that, manipulating strings. So as many of these things that we start seeing as sort of a common wheel of policy, bringing that into a standard lib. Then there's a notion of sort of enforcement levels, right? It's not that sort of all policies are created equal. And so what we found is, you want to have this sort of awareness of at least 3 different levels of policy: advisory, soft mandatory, and hard mandatory. And basically, an advisory policy is kind of what it sounds like, right? It's allowed to fail, and what happens if it does fail is we just provide a warning. And so these can be things like, this type of instance class is deprecated, the user should just know that. We'll just issue a warning if they're provisioning it, but otherwise don't stop this action from taking place. The next level becomes something you want to stop generally, but there might be circumstances that you should be able to escape that policy. Right? So a great example of this is like don't allow changes outside of business hours. Right? So you define that window, but it might be that the site is actually down at 2 in the morning, and there's a good reason to be doing a deploy outside of business hour. And so if it's a soft override policy, you can set an explicit override, so you as a user are still acknowledging that, yes, I know this is in violation of the policy, but I've acknowledged that and I'm overriding it, as long as you have sufficient privilege to do it. And the last category is things that you just cannot override, right? It's like they must pass, there's no escaping it. It's things where like your regulators are gonna be really unhappy. Like every key just has to be 128 bits. Like, sorry. And so this is all integrated into sort of the runtime. It has this awareness of this because it changes the way you'll do short-circuiting, right? So if an advisory policy fails, you can't actually short-circuit. You have to keep evaluating the other policies. But if you get to a hard mandatory policy that's failed, there's really no point in bothering to evaluate the rest of the policies. Like, you're not gonna let that request through anyway. And so by having this, it sort of lets you break it out into these smaller policies as opposed to these monolithic policies, and just install a ton of them to handle all the different sort of use cases. And so this really covers kind of the runtime, which is designed to be embedded. So by being in the data path, it lets us do this sort of active enforcement. So you don't have to detect sort of post hoc that you've deployed something that's in violation. You just prevent it in the first place. But then you end up with this interesting question, which is like, how do you actually develop and test these policies if it's embedded, right? How do you deal with it? So this is where the simulator tool came from, is how do we actually let that user experience around writing this be a lot nicer? And so the simulator has a few commands. One is sort of apply, to be able to actually test the policy and interact with it. One is doc, so it sort of has a sort of a canonical format of documenting things and sort of emitting a documentation around the policy. The FUMPT to have that canonicalization, and then test, which we'll talk about, provides sort of a test framework around policies. So apply kind of does what you'd expect it to do. You can pass in a policy, and it'll show you the sort of execution trace of it to sort of debug and interactively work with a policy and understand, why did it pass, why did it fail? And so it'll give you some feedback in terms of like, what were the clauses that caused your overall policy to go wrong? But that's really only useful when you're like sort of like live writing it, testing it, that sort of like interactive write test loop. What you eventually want to do is kind of exactly what we do with software, which is have sort of test suites and regression testing, right? So how do we actually start defining tests so that we can, under situation A, B, and C, the policy should pass, and under X, Y, Z, it should fail. And so we have sort of this layout where you can define for your policy sort of the passing tests and the failing tests. And then for each test, you basically can assert, given this mock input, so if the time of day is, this, I expect the overall policy to go false, right? And so you can set up all of the different scenarios and sort of stress test the kind of edges of the policy. And then you just run the full test suite over it. So for a particular thing, you can run all the, supposedly passing, supposedly failing tests and make sure that it actually matches. And the goal of this is you kind of do the same thing you do with code, which is put it in a CI system. So as you're writing and testing policy, if you're like, I'm going to add this new clause, you make sure it doesn't sort of break the system, right? That it doesn't inadvertently allow behavior it shouldn't. So the last piece is the import SDK, is how do we actually allow you to make decisions based on external information. So oftentimes what we find is that policy decisions can't really be made in isolation. It's sort of a coordination across multiple different systems. And so you really need a way to sort of source information from an external system and use that for a policy decision. And so this was the goal of having an import SDK, is it allows you to sort of define your own plugin and then use IPC to basically query these external systems. And so the runtime, I mentioned it, does some work to make this efficient, because as you can imagine, forking and execing a plugin for every request would be pretty prohibitive. So the runtime does some things around fork it once, maintain it if it's not used for some amount of time, garbage collect it, and then multiplex multiple requests to the same plugin, so that you don't need 500 plugins running at once. And so the goal really ends up being a fewfold. One is that over time, we want to have sort of an ecosystem of these plugins for common systems, but that it makes it possible to integrate with your custom internal systems. And you can sort of also extend it with arbitrary logic. So you can have a plugin in some sense that's not calling out to any system. It's just implementing sort of user-defined functions. And some of the stuff that we see that becomes neat about this is the sort of cross-system protection, right? Is that if I submit a job to be scheduled, to my scheduler, and say I want to start a web service, that thing can then call out to the configuration system and say, is the service actually configured? Are you trying to launch a system without any configuration set for it? In which case, reject it. And then likewise, are you trying to delete configuration for a system that's currently running in production? Like you can't delete the config of a running system, right? Go stop the system first, and then you can go delete the configuration for it. So sort of the high-level use cases that we think about policy as code is at least these sort of three big ones that we've seen come out. One is this notion of how do we have these guardrails around infrastructure as code, right? How do we get back to that sort of somebody is sanity checking when we ask for 5,000 VMs? The other one that we find is very useful, sort of simplifying the compliance story, is just instead of a detection and remediation workflow, you just prevent the activity to begin with. It's just like now we don't need to worry about what our remediation looks like. And the last one is the sort of like fool me once, shame on you kind of a thing, which is we all make mistakes, but how do we keep ourselves from making them again? And so we'll sort of talk about that. And so this one sort of we've talked about a few times. It's really about defining that sandbox and imposing the sanity checks without having kind of a manual process. The compliance one is really about translating kind of the Word document form into an actual codified form, and that way we can automate the enforcement of it. And so really what it lets us get to is the sort of ounce of prevention scheme, right? So we're not dealing with, now we need the sort of hourly detection of anything that's out of violation. It files a ticket and pages you, and now you have to go kind of remediate it and sort of, you know, let the auditors know. It's like, well, it just couldn't happen and it didn't happen. And then this last one is really realizing that the policies will never be exhaustive. They'll always be sort of the edge of the sandbox or some way to screw something up in production. And so in some sense, what happens is oftentimes we stub our toe, and then we're like, okay, I'm going to remember next time, you know, not to deploy a service without, you know, actually having configuration set for it. The problem with that is our memory is finite, right? And there's only so many things that we're going to recall to check and make sure, like, oh, did we handle that edge case? And so in some sense, this gives us a framework to codify against that. So yeah, the first time I deployed my, you know, instance to production without configuring it, shame on me. The second time around, I wrote a policy so the system was like, no, you didn't configure it, go configure it first, right? And so it's sort of much easier to scale this set of policies than it is to scale our memory, right? So in conclusion, you know, policy as code really is building upon this existing kind of idea of as code, is how do we take these processes, codify them, have the single source of truth, and sort of get all the codification benefits. So it's sort of shared with everything from infrastructure as code, shared with what we've learned in software development. And Sentinel is just sort of one play at it. It's our sort of stab at doing this policy as code thing. And it's sort of composed of a few different pieces. And our view is sort of, this is what it's going to take to get to that next step in infrastructure automation, is having more of these guardrails so that we can do it, you know, with some sense of comfort, instead of saying there's 3 people that we trust enough to actually go out and automate this. And that's all I have. Thank you guys so much.